In this video, we will describe some common troubleshooting tips for BMSEED's Electrophysiology module when using stretchable or glass microelectrode arrays. Section 1. Initial checks. Before diving into troubleshooting, always check the basics. Confirm that the MEA is placed in the correct orientation in the EIB. There are two orientation options, standard and 90 degree. Make sure the proper INTAN mapping file is loaded based on the sample type and orientation. Verify your reference electrode setup. Are you using the correct jumpers or an external counter electrode connected to the EIB? Inspect the MEA under a microscope for any bubbles at the recording sites. Degas the sample to remove any bubbles. Finally, double-check that all cables and connectors are properly connected. Additionally, double-check that port A is connected to head stage 1 and that port B is connected to head stage 2 on the 60-channel EIB, or that ports A through D are connected to head stages A through D, respectively, on the 120-channel EIB. Section 2. Some channels show high impedance or noise. If only a few channels are affected by high impedance or noise, start by cleaning the MEA pads and EIB pogo pins with ethanol or isopropanol and check that none of the pogo pins are stuck in the compressed position. Add a booster PCB if needed to promote contact between the MEA and the pogo pins. Rotate the MEA to the 90-degree orientation, reselect the appropriate mapping file in the INTAN software, and see if the issue follows the MEA or the EIB pins. Finally, swap the head stages and see if the issue follows the head stages or the MEA channels. You might need to restart the INTAN software since the SPI cables were disconnected. Section 3. All channels show high impedance or noise. This usually points to grounding issues or electromagnetic interference. First, confirm your grounding connections. If using an external reference, is it fully submerged in the solution? Additionally, test whether connecting the EIB to the INTAN chassis or I/O ground minimizes the noise. Next, isolate the INTAN controller to a dedicated power outlet. Add ferrite loops to the INTAN's USB cable using the provided ferrite core. If needed, place the EIB setup in a Faraday cage or aluminum foil for maximum shielding. Short the EIB to the chosen shielding. Section 4. Sinusoidal noise at 50 or 60 Hertz. If you see a consistent sinusoidal pattern in your recordings, try to shorten and bundle your grounding wires. Additionally, ensure that no light can reach the MEA recording sites or head stages and that all thumb screws are properly secured. Try placing the EIB setup in a Faraday cage or aluminum foil for maximum shielding and short the EIB to this shielding. Additionally, test whether connecting the EIB to the INTAN chassis or I/O ground minimizes the noise. As a last resort, enable a digital notch filter in the software window, but only if the physical solutions aren't working, as this can introduce artifacts in the recording. Section 5. Red highlighted channels. A red highlight over the channel often means surface impurities or faulty connections. Start by cleaning the MEA pads and EIB pogo pins with ethanol or isopropanol. Rotate the MEA to the 90-degree orientation, reselect the appropriate mapping file in the INTAN software, and see if the issue follows the MEA or the EIB pins. Finally, swap the head stages and see if the issue follows the MEA or the EIB pins. Additionally, double-check that all cables and connectors are properly connected. Finally, double-check that the MEA is connected to head stage 1 and that port A is connected to head stage 2 on the 60-channel EIB, or that port B is connected to head stage 2 and that port C is connected to head stage 2 on the 120-channel EIB. Section 6. Sine-Soidal noise at 50 or 60 Hertz. If you see a consistent sinusoidal pattern in your recordings, try to shorten and bundle your grounding wires. Additionally, test whether connecting the EIB setup in a Faraday cage or aluminum foil for maximum shielding. Short the EIB to the chosen shielding. If needed, swap the head stages and see if the issue follows the head stages or the MEA channels to determine if a hardware or sample replacement is necessary. You might need to restart the Impedance software since the SPI cables were disconnected. Section 6. Software crashing while stretching with MEASSuRE. This issue is mainly applicable to MEASSuRE X. If the software crashes when the actuator is running, electromagnetic interference is likely the cause. Add ferrite loops to the Impedance USB cable using the provided ferrite core. If possible, increase the distance between the VCA and your PC. Lastly, if your experiment allows, lower the VCA input voltage on the power supplies until the software crashes disappear. Section 7. Still need help? If your problem isn't resolved, reach out to BMSEED directly. Send us photos of your setup with the MEA, reference electrode, and jumper plug. Take screenshots and 10-second RHS recordings of the Impedance signals in the standard and 90-degree sample orientations. Include details about your mapping file, booster PCBs, and sample ID. The more information you can provide, the faster we can assist you. If you have any questions about troubleshooting BMSEED's Electrophysiology module, contact BMSEED directly or refer to our Electrophysiology troubleshooting guide.